Okay, so here's the third problem, and this is where the no calculator section begins. So a continuous function g is defined on the closed interval given here. The graph of g shown above consists of 3 line segments and a quarter of a circle centered at the point 0, 2. Let f be the function given by this. Guys, what you've got to realize, okay, this is an accumulation function, all right? And when you take the derivative of an accumulation function, let me do it like right here. I'll do it right here. So I'll do d dx on both sides. So f prime of x is equal to, right, and this can be done in your head, what I'm showing. Okay, so when you are taking the derivative of an integral, that's an accumulation function. So, and if this, so this is basically the final time is x, and it's changing. So if this is the same as the variable that you're differentiating with respect to, then all of the integral stuff just cancels. But this t is a dummy variable, so whatever this variable is here goes inside of that. Okay, so this is equal to g of x. So you have to make an observation here that g is f prime. Okay, so you're given the derivative graph here. All right, so that's a crucial observation that needs to be made. Okay, so find all values of x in this interval, so the open interval. Oh, so not including the endpoints. Okay, at which f has a critical point. Classify each critical point as the location of a local minimum, a local maximum, or neither. Justify your answers. Okay, so I'm looking for where f has a critical point. All right, so if you want to do this, even if you don't write out a derivative sequence, guys, you always want to be thinking about a derivative sequence and how you're moving within it. So, where does f have a critical point? That would be where f prime is 0 or undefined, and nothing special about f double prime. Okay, so guys, this is the graph of f prime. It's g, but I established here that it is f prime. So I'm looking for where this graph is 0. And 1, 2, 3, 4, 5. So -6 and 2. All right. So critical points at which f, okay, so critical points at x equals -6 and x equals 2. Okay. Justify your answers. All right, so let me say at the beginning, since g is equal to f prime. Okay, so, and if you wanna, maybe this would be better. You could say since g of x. Okay, but you don't need to do the of x if you don't want to. All right, so either of those is good. And, okay, so we got critical points there. Critical points at this because g of x, which is equal to f prime of x, is equal to 0, okay, at those points. And if you just said g of x, you established they're the same here, so you don't have to do like a 3-part equation like I did, but that's good. Okay, so now, local min or local max or neither. Okay, guys, so, all right, well, we want to be looking for a sign change. All right, so this is the graph of f prime, okay? And this at this critical point, f prime is changing from negative to positive. Okay, so a min on f is when f prime changes from negative to positive, and a max if f prime changes from positive to negative. Okay, so that's what I'm looking for. So here I've got a min, and then here we're changing from positive to negative. Okay, and all right, great. So I could say local min at x equals -6 because g of x, which is equal to f prime of x, changes from positive to negative. Local min, oh, no, max, my bad. Local max at x equals 2 because g of x, all right, I won't belabor the point, because g of x changes from positive to negative. Okay, guys, and that is 3 points. Okay, 3 points right there. Okay, so now this one. All right, so this is 2 points. Find f of 0. Okay, so let me just carry this over that I know that f of x is equal to the integral from -8 to 0. Okay, so this is the area under the curve from -8 to 0. So I got to look at this, and -8 is there all the way up to 0. Okay, so we're going to have that little triangle like that. So, guys, I just want to point something out to you. If you notice that these two, okay, so I'm doing the area under the curve here, and this is a forwards interval, so the base is positive. Here I have a negative height, but everywhere else the height is positive, okay? So this is a negative area, and then this little triangle here is a positive area. Guys, these two areas are going to cancel each other out because you're going to get the same number, but this will be negative, that'll be positive. So that's a great observation, guys, if you can make it. Then you don't have to do 1/2 base times height for each of them. They're just going to cancel anyway, okay, which is really nice. So those are going to make 0. All right, so those areas cancel. And, okay, so now I'm going to add the area of this rectangle to the area of this quarter circle. Okay, so pi r squared, but divided not in half, in fourths. Alrighty, so the base is 1, 2, 3, 4. The base is 4, and the height is 2. 4 times 2 plus pi r squared divided by 4. Okay, and the radius of this circle is 4. Okay, so I'm getting 8 plus 4 pi. Okay, 2 points. All right, now this one. So find the limit as x approaches -4 of this. So when you're doing a limit, the first thing, guys, is direct substitute. So this is equal to f of -4 over 0. Okay, now, if f of -4 is 0, then I have 0 over 0, then I can use L'Hopital's rule. So I have to go f of, oh my gosh, and it is 0. Okay, f of -4. All right, so let me, so f of -4, I can actually just do it down here. f of negative 4 is equal to from negative 8 to negative 4. Okay, and this is what I was talking about earlier. So from negative 8 to negative 4 would be these two triangles added together. That is 0. Okay, so that is 0. So this is 0 over 0. Okay, so now you could use L'Hopital's rule. So you have to say, therefore, by L'Hopital's rule, okay, and then I'm going to take the limit as x approaches negative 4, and I do the derivative of the top over the derivative of the bottom. Excuse me. So, all right, so this is the limit. Okay, the derivative of f is just f prime, and then the derivative of the bottom, 2x plus 4. Okay, then I direct substitute again. So I'm getting f prime of negative 4 over negative 8. Negative 8 plus 4 is negative 4. Okay, now f prime of negative 4. I have to find that. And guys, f prime is this graph. Okay, so f prime of negative 4 is this, yeah, f prime of negative 4 is, oh, I'm sorry, I'm blanking. F prime of negative 4 is the y value on this graph. Okay, so I go to negative 4 on the graph, and the y value is 2. Okay, so this is equal to 2 over negative 4, which is negative 1/2. Okay, 2 points right there. All right, finally, actually, I don't know. I couldn't find the scoring rubric for this, so I just took an educated guess on 2 and 2 here, guys, but this could very well be 1, and maybe this is a 3. That seems more, that's how I would have done it, but okay. So now let h be the function defined by this. Find h prime of 1. Guys, you're taking the derivative of this. So you ask yourself, is this a one step? No. If it's not a one step, you got to start thinking of your derivative rules, and this is a quotient. So I'm going to use quotient rule. So first I have to find h prime of x, and then I'll plug in 1. So h prime of x. I'm going to set up quotient rule very carefully, but you could skip steps. So d dx gx minus, okay, all over that. Okay, so we've got h prime, still h prime of x equals minus, okay, so this is going to be, the derivative of this is 2x, so I just wanted to put that in front. Okay, and now I'll plug 1 in. And then this is 2. And then this is 2 squared on the bottom, so that's 4. Okay, now I just need g of 1 and g prime of 1. So you got to remember what g is. Okay, so g is this graph here. G is this graph, same as f prime. So g of 1 is the y coordinate. Oh boy, it's kind of hard. Is the y coordinate that we get here. Okay, now guys, I'm looking and I see it really looks like 1, 2, 3, okay? But how can I like verify that it is? you could use similar triangles, like just to verify. So see how this is a similar triangle here? All right, so I've got that little triangle that I just drew, and then this larger triangle that it's inside of. Oopsie, and they're similar. Okay, so their sides should be proportional. So, so let me do it over here. Now it turns out that if you just like, thought it was 3, you'd be right. Okay, but I want to ensure that this here is 3. I'm pretty sure that that's 3 there. So that this is 3. Okay, so this whole thing, yeah, so this is 1. So that's 1, and that's 2. Okay, and then, so this should be 6. If this is 6, then the proportion works. And 1, 2, 3, 4, 5, 6. Yes, it is. Okay, so in fact, this is the situation that I have going on here. So that y coordinate is 3. All right. So the little triangle, if you multiply it by 2, you get the big one. All right, so that works out. So I know that I'm right, that is for sure 3. Okay, so anyway, so g of 1, I'm just crossing it off lightly so my reader can see where it's from, is 3. Now, this will help us what I just did too. G prime of 1, this is the slope. This is the slope at 1. So I need the slope of this line. Okay. And guys, the slope of this line is just rise over run. So like from here to here, I'd go down 6 and then right 2. Or we could go down 3, right 1. But in either case, the slope is -3. Okay, so let me just say, this is m tan. That's the same as m tan. And in this case, it's -3. Okay, almost there. So we've got, all right, -3 times 2, that's -6 minus 6. Oh gosh. -3. Okay. All right, guys, there it is.